Okay, let's go ahead and get started. This is going to be a relatively short lecture today. We are just going to talk about Lab 7, go through a little bit of things on that, do a little bit of coding for that. So hopefully you'll all be successful with that. And I'm going to go ahead and go through a couple things with that. So first off, before we look at the lab sheet, let's talk about how to make a moving cannon that can shoot. And we kind of already had bullets coming out of where the mouse position was, but we want to make something we can move kind of with the keyboard. And we'll make it so it can move kind of along the left side of the screen, I guess from your point of view over here. We'll make it so that cannon moves up and down like this and fires bullets go across the screen. And that's going to be different from what you need to do for your lab. For your lab, you're going to need to have the cannon move along the bottom of the screen. And when it shoots, the bullets are going to go up. But it's very similar. So what we're going to do is we're going to look at that code we had from last class. So let me switch over to that for a second here. I want to do that. And let me go bring up that Python program from last time. So here's the code we had from last time for that OOP bullet example. Just a quick overview. We had this bullet class, and the bullet has an X and a Y position, an angle, a speed, a color, a size, and whether it's alive or not. And then it moves and it renders. So render, we're just drawing a circle. Moving, we basically just say use the direction, the angle, and the speed. Use sine and cosine to calculate the displacements in X and Y. Add those to its position. And then if it hits an edge, goes past an edge, then we set it alive to false. Now in our main loop down here, we basically go through and say, hey, for every bullet that's in the bullet list, move it, render it, and if it's alive is now false, then add it to this list of ones to remove. And then we go through that list, and if there are any that need to be removed, we take them out of the list. All right, now let's go ahead and run that just to remind ourselves how this worked. So last time we had this code where if I press the space bar, it'll shoot bullets out of the place where the mouse is. Now we want to do something similar to that, but we want a cannon. We want that cannon over here on the side, and we want to be able to use the arrow keys to move it up and down. We'll still use space to shoot. And notice we had a little bit of variation there. We can make with a cannon, we can make them shoot directly to the right. But let's go ahead and add that code in there. So the way we're going to add that code is I'm going to do, again, a little object-oriented programming here. So I'm going to make a class. I'm going to call it cannon. And I'm going to have a constructor, so def underscore underscore init underscore underscore. That's the special name for that, self. And here, rather than having the cannon being able to start out in a certain position, I'm just going to stick it all the way on the left of the screen. So here's self.x. We'll set that to 0. We're not going to allow the x to really change, but I'm going to give it an x anyway. Self.y. I'm going to put that right in the middle. So remember, it's 800 by 600, so to put right in the middle, that's going to be 300. And really, that's all that I'm going to have for the cannon right now. And really, we could just get by with a Y, but I'm going to put an X and a Y just to have that there. Now, I'm going to have a render. And remember that self parameter is always the first thing in any of these object functions, any of the methods, and that gives it so that this object can access its own attributes. So in this case, to draw this thing, we're just going to say self, or let's do pygame.draw. And let's draw the cannon with just a little rectangle. So rectangle onto the display surface. And the color, let's make the cannon blue, so 0, 0, 255. And if you remember the way a rectangle works in Pygame, is we give it, the next thing is a rectangle, which is kind of like a color has 3 parts. A rectangle has 4 parts. So this next thing we're going to have here has to have 4 parts. So this is going to be the upper left corner. So I'm just going to put that at self.x, self.y. And we're going to change it in a second. Now we need the width. So the width in this case, let's just make it like, let's make it 20. And let's make the height 10. So we're making a little rectangle that's 20 wide, 10 tall. And then we want that to be filled in. Now, we're also going to need to have a way to move it. And what I'm going to do here for the move for this is rather than a move, because it doesn't really have a dx or dy, I'm just going to have a move up. And to move up, we're basically going to take self.y and do minus equal. And we'll do minus equal, let's just do minus equal 1 for right now. And then we have to check that. So we're going to say if self.y is less than 0, then set self.y equal to 0. So that way it can't go off the top of the screen. And now we're going to make a move down also. So we have move up. Let's make a move down. And move down, self.y plus equal. And if self.y ever gets to be greater than 599, then set it equal to 599. Okay, so now we have that. And one thing I might do on this, if I wanted the x and y to be in the exact center of that cannon when it draws it, then we might want to draw this a little bit differently and have some offsets in here, but I'm going to leave it like this for right now. Now, there is probably a little bit of a problem here that we'll see when we go to run this, but now we have that object created, or that class created. Let's make one. So let's call this cannon. And to make an object of that, cannon is going to be equal to cannon. So we are basically just calling the cannon class. And notice, again, because I used a capital on this, that sets that apart from a variable down here. And to make this a little more clear, rather than saying cannon equal cannon, let's call this player cannon. Okay, so now we have that cannon. So now in our code, what I want to do is I want to render that each time. So before we do the display.update, let's render it. So let's do player cannon.render. So it's going to draw it. And now let's add the code in here under the keyboard stuff here to allow it to move. So up here, I'll just add some key presses. So let's say if keys sub pygame.k underscore, let's do W and make that be up. So that's going to be player cannon.move up. So in other words, when they press W, we call move up. And now we're going to do the same thing, except this time instead of W, I'm going to use S to move down. Move down. And let's run that and see what happens. All right, so there's my cannon over there on the side. Notice it's blue, just like we want it to be. And I can move up, and I can move down. All right, if we wanted that to be faster to move up and down, so I'm pressing W right now, it's moving up. I'm pressing S, it's moving down. That's exactly what we wanted, and it's rendering it each time down the loop. And notice that now we want to add it so when we fire, the bullets come out of, oops, that's not what I want to do. Let me go back to that. I want to make it so that when I fire, the bullets come out of the end of the cannon. Right now, when we press spacebar, notice what it's doing. Here's spacebar. We're putting them at the mouse position. So really, to change this is going to be really easy. We're going to basically take that and that out. And here, when they press spacebar, what I'm going to do is rather than putting the bullets, creating a bullet at the X position that's where the mouse was, we're going to do player cannon.x, player cannon.y. And here the direction, instead of having a random variation in the direction, I'm just going to make it always go at 0 degrees. So it's always going to go directly to the right. Now, let's run that again and see what we get. So there's the cannon. I can move it up. I can move it down. And when I press spacebar, now notice that there's something, this is why I said that was a little bit weird how we were drawing it. Notice the bullets are coming out of the X and Y, which was actually this upper left part of the cannon here. It would be better to have the cannon based rather than around that X and Y being that upper left. It was around the middle or even this end over here. So the end of the cannon, and have the bullets created there. So let's change how we're drawing the cannon. And one more thing, let me show you one other bug that we have here because of the way we did this. Is notice when I go up to the top, it makes sense. It stops right at the edge. When I go to the bottom, you'll notice something bad will happen. It'll go off the bottom edge. But if we draw it from that middle position, let's make that cannon a little bigger since you guys might be having a hard time seeing that. Let's make the, so again, we go to the cannon object. Here's the render. Let's make it 40 wide by 20 tall. But now what I'm going to do here is for this X and for Y, what I'm going to do is I'm going to make it so the end point of the cannon, in other words, here, let me run this again real quick and look at, I want to show you where I'm talking about. We want the X and Y to be this point right here. So right on the very end of that cannon is where we want the bullet to come out. Now, how can we deal with that? Well, if that's the X and Y, then notice that this position here, when we go to draw the rectangle, has to be that X minus the width and then minus half of the height. So what we're going to do is we're just going to change the way we're drawing that rectangle. And that also means in the cannon, let me scroll up here to where we are. So this self.x here is going to be the X minus 40. And over here, self.y, since we want half of that, we're going to do minus 10. So in other words, minus half of it is, half of 20 is 10, and all of that 40. But that also means when we create the cannon here, we want the end of it to be 40 pixels over. And now you'll notice that it doesn't have that problem anymore, that it stops halfway there. And it starts at, so the point we're looking at the X and Y is right there at that end. And now when we fire, you notice the bullets are now coming out of the end of it because that's where the X and Y is. And if we want to increase the fire rate, we added that cooldown last time. So remember, we can change that. And if we wanted to, there's actually a cool way we could deal with this that we'll look at a little bit later on, is rather than having this just draw the bullet there, we could actually have the fire add the bullet to the bullet list if we wanted to. But right now, we'll just leave it like this. But let's increase this rate. Let's make the cooldown less. Let's make it like 10 frames. And since we're running at 120, now you notice we get a lot more bullets. That might be too many, actually. Let's make it a little slower than that. Let's maybe make it 30. Oops, let me move that over, you can see it. Okay, so now we have our bullet with our cannon. Now this is going to translate and if we want that cannon to move up and down a little more quickly, maybe the gameplay is feels a little sluggish, we want to make that move a little more quickly. Rather than increasing the frame rate, remember what we can do is we can just go up to the cannon object. We can say, okay, well, I'm moving it by 1 every time. Let's just move it by 2 every time instead. And now we'll move 2 pixels rather than 1 each time. And now you'll notice that it moves, hold on. Now you'll notice that it moves twice as fast in the up and down direction. And we can kind of balance the rate of fire versus the, and maybe we say, well, the bullets are moving way too slow. Let's fix that too. So with the bullets moving too slow, the default speed for those, remember, was 1.0. Let's override that. So let's come down here on the code when we create the bullet. And let's set the speed equal to 3. Okay, that looks a little better. Okay, so the next thing that I want to do quickly is let's go back to, so now we have a cannon. So this is kind of what you're going to have for your game. But let's go back and look at the what we're talking about for the actual game here. Okay, so we modified that example code from before, and now looking at this stuff here, that was a pretty good start that we had back here modifying that code. So we could now, you could make this cannon, you can make that move back and forth. There's a triangle here instead of a rectangle, but you can figure out how to do that. We've done stuff like that before. And then, So just pygame.draw.poly, and then the X and Y would be here, and you go over and down, back here, back there, connects the dots, draws that little polygon to make that cannon. And here are the bullets going up, just like we had them going to the side. So in other words, these would be the Y changing, getting less each time, rather than the X getting bigger each time. But the code that we just looked at is going to be very similar to what you're going to need to do for this asteroids game that we have here. Now, the way this is going to work, let's take a look at the lab. And actually, let's just look at this picture over here and talk about what's going to happen. So what's going to happen is these asteroids, these red circles that we have here, are going to spawn at the top edge randomly. It's going to pick a random position along the top edge. So the X is going to be random, but the Y is going to always start at 0. And when it draws those, they're going to slowly move down the screen. So just like the bullets are moving up, the asteroids are going to move down. And if an asteroid ever hits the ground, some of our population dies. And if the population gets to 0, the game is over. So this is kind of like a tower defense, except it's kind of Earth defense game. And the idea here is pretty straightforward in that we are going to be firing that upwards. These are going to come downwards. And what happens is when a bullet hits an asteroid, we want to remove the bullet from the bullet list. We want to remove the asteroid from the asteroid list. Also, you're going to have this timer counting up down here. How many seconds have you survived? We've done timers before in the past. This, notice, is going to be a whole number of seconds, though, so that's pretty easy. Just take the int of the amount of elapsed time to get that. And then you're going to use a font to print out how many bullets are currently on the screen, how many asteroids are currently on the screen, and what your current population is. So in other words, as you fire the bullets, this number will go up, and then as they leave the top of the screen, it'll go back down. All right, so let's pop over and take a quick look at the lab sheet here. And there's a couple other things that I want to explain about it. So let me show that real quick. Okay, so here's the lab sheet. Let me make this so you can see it a little better. Maybe there. Maybe there. Let me zoom in. Okay, so the idea here, the program overview basically says, describes the thing that the asteroids are falling. You've created this Earth defense cannon. You're going to shoot that. It's going to shoot bullets. It's going to hit the thing. So the first thing is we want to lock the frame rate of the main game loop at 120 hertz. We know how to do that. We basically make a clock object. So pygame.time.clock, and then you do that clock.tick, FPS clock.tick, put the 120 in the parentheses, and that'll lock that at 120 hertz. Now, if you want, you can draw a star field in the background. I think it adds a lot to the game to have that star field kind of twinkling in the background. Those little details like that can help out tremendously with how a game feels and how it looks. So you're going to allow the player to move the cannon left and right using the A and D keys or the left and right arrow keys. So either the arrows or A and D, either one. When the player presses the space bar, we're going to create a new bullet at the location of the cannon. The bullet should then move upwards on the screen until it hits the top of the screen. If the bullet reaches the top of the screen, it's removed from the list of bullets. Now, we already have code that does something similar to that, except it's left to right rather than bottom to top. So easy to switch that around. Now, every time through the game loop, it says create asteroids that fall from random locations at the top of the screen. There should be a 1% chance of creating a new asteroid for every pass through the game loop. Now, how do you do a 1% chance? Well, make a random number 1 to 100 if it comes up 1. So if random.randint 1, 100 equal 1, then that's a 1% chance. So add a new asteroid to that asteroid list. And notice with this running at 120 hertz, that's going to give us about 1 new asteroid every second, a little less than a second. So about 0.85 of a second or whatever that comes out to be. So you're going to have this new asteroid, new asteroid, new asteroid kind of like, but since it is random, it might be a span of time where there aren't any, and then you'll get 3 of them really quick, and then a span of time where there aren't any. But you're going to, every 10 seconds or so, you're going to get about 10 asteroids, maybe a little bit more, 10 or 11 asteroids. Now, the idea is when you're shooting and those bullets are going up, if a bullet hits an asteroid, we want to remove both the bullet and the asteroid from their lists. If an asteroid hits the bottom of the screen, it should be removed from the asteroid list, and some of the population should die. So how do we tell if the asteroid hits the bottom? Well, if its Y value ever gets to be to the point where it's at the bottom of the screen. How do we tell when the bullet gets to the top of the screen? Well, its Y value gets to be less than or equal to 0. It gets removed from the list. Now, if the planet's population gets to 0 or less, then the game should end. When the game ends, display a game over mess screen that tells the player how long they lasted. And display on the screen the number of bullets in play, the number of asteroids, the remaining population, and the time elapsed. So just like we had over here. Now, one of the things that I would suggest doing for this program is to use classes. And you're probably going to want to have several classes. You probably want to have that cannon class like we did as well. But notice we're going to have a bullet class, an asteroid class, and maybe stars if you have that star field. Maybe the cannon if you have the cannon. And this lab, notice that there's a chance to get a lot of bonus points. So if you missed points on the midterm, or missed points on a quiz, or missed points on one of the previous labs, or you just want to bank some points for the final exam that's coming up shortly, that you can get up to 20 whole bonus points here by doing these things. So 5 bonus points for when it hits the ground, make a crater. And the crater should stay around until the game ends. In other words, I added that feature here so you can see an asteroid has hit there, and there, and there, and there, and there. And it makes those craters. Add sound effects and background music using the Pygame sound and music commands. We haven't talked about those really, but those are pretty easy to figure out. If you search for Pygame and sound and Pygame and music, you can figure those out. And actually, I am going to talk about those after the final exam. So after Thanksgiving break, we're going to talk about how do you make sound, how do you make music. We are going to talk about that a little bit. And then also 5 points for using images for the asteroids. So rather than circles like I have up here, use an actual image. And one of the things that's cool you can do is you can actually go to, that I did when I made a version of this, and it makes it look a whole lot cooler to have like these actual images, is you can actually go to like NASA and type NASA and asteroid and do an image search, and you can find pictures of actual asteroids, and those images are royalty free. Or you could use Photoshop or GIMP or Paint.net or whatever, and or Microsoft Paint, and you could use the Paint tool and draw your own asteroid and make it look very cartoony if you wanted. So it's up to you how you do that, but use images. Use at least 3 different images. Now, if you use different images, and that means this asteroid might have a different image than that one, might have a different one than that one, or that one, or that one. Think about how you would do that, and what I would do is think about this asteroid class. Well, it could have an attribute that is the type, and that type could be like 1, 2, or 3. And then in the render for that, you'd say, hey, when you go to render, if the type is 1, use this image. If the type was 2, use this image. If the type was 3, use this image. So think about how you would do that. You could actually even load into the asteroid the surface that's used for it. And then you wouldn't need that if statement. But anyway, the last one is draw little people at the bottom of the screen. When I did that one myself, I drew little stick figures and they walked along the bottom. And I made it so when an asteroid hit them, they got squished and they screamed. You don't have to do that, but if you make little stick figure people that kind of wander back and forth here kind of randomly, and then they get hit by an asteroid, they get killed by anything in that radius, they die. Now, that's the lab. And it actually, especially if you add the twinkling stars and you replace these with images and you add the sound effects, this actually turns out to be something that looks really cool. But it's really, especially if you use that object-oriented programming like we talked about, this ends up not being as something that looks really cool, but actually not that difficult to do. So the main thing that I want you to think about with this particular lab is how to do it in kind of that object-oriented way to make sure that you have the bullet objects, and you make a list of those. An asteroid object or an asteroid class, and you make a list of those. And then the biggest challenge on this one, and I'm going to switch back to the presentation for just a second here, because I want to talk about something here. The biggest challenge in this one is how do you detect when bullets hit asteroids? So for example, how do we know that this bullet is not colliding with that asteroid? And the answer to that is to use the distance formula. So in other words, if the distance from this bullet to that asteroid, from the center of that bullet to the center of this circle over here, if that distance is greater than the radius of this one and the radius of that one added together. So in other words, if radius 1 plus radius 2, you take that sum, and if the distance ends up being greater than radius 1 plus radius 2, you know they're not colliding. So the only way they can collide is if the two radii of those two things overlap. So to show you kind of what we're talking about, let's say here's the asteroid, here's the bullet. The only way these will collide is if the radius of this one and the radius of this one are added together. The sum of those two ends up being such that the distance between them is less than or equal to that. If it's equal, they're just barely touching. If the distance between the centers is less than that, then they have to be overlapping. So that's what we're going to do. We're going to use that distance formula from the center of an asteroid to the center of a bullet. And if it's smaller than or equal to the sum of the two radiuses of those, the bullet size and the asteroid size, then we know that they're colliding. And then we need to remove them from the list. Now, how do we get them to be removed from the list? How do we detect the collisions? Distance formula. How do we check all of them against every other one? Well, we need to have a nested list. In other words, go through every bullet and then check every asteroid for every bullet. So in other words, check this bullet. Is that one colliding with that one? No. Is it colliding with that one? No. Is it colliding with that one? No. So we go through all of them. And if it's not colliding with any of them, then we're okay. But then we need to go to the next bullet in the bullet list and check the collision of that one with all the asteroids. And if that one's not colliding, then we go to the next one. And now if I find one that is colliding, then I need to remove that bullet from the list, and I also need to remove that asteroid from the list. Now how do we remove them from the list? The same way we did when they left the screen. We just mark them as, put them in a bullets to remove list, a asteroids to remove list, and then have a loop following this nested for loop that basically says, go through all the ones that we need to remove and remove them from the bullet, remove all the bullets from the bullet list, all the asteroids from the asteroid list. So I'm going to let you figure out how to do that, but this nested loop is the key for checking every bullet against every asteroid. So how do you check to see every bullet against every asteroid? Make a nested loop, one loop inside the other one, and then just check the distance, and if they're too close, mark both of them to be removed from the list. Don't remove them right then, because that'll change these lists we're going through, but add them to that bullets to remove list, and then after that, go through that list and take any of them out that need to be taken out. And you can look at that other code that we did in order to know how to mark them for removal. You could say alive equal false for each of them, or you could just add them to that list, and then if they're in that list, then take them out. Okay, so that's all for today. I want you to work on Lab 7, also study for that final exam that's coming up, that paper part anyway. You will also want to eventually finish that lab anyway, and working on that lab is a good way to study for the exam because there's going to be some questions about objects, some questions about other programming related things. So just make sure you're prepared for that. The study guide is on the course site. The practice problems are on the course site, so make sure to go through that and do that. And if you have any questions, send me an email or a text message or a message on Discord or something. And other than that, stay safe, and I'll see you guys for the final exam.